Hey there, my name is Rashay Gupta, and today I'll be talking about inversion and the process of mounting rigid objects to soft robotic structures. So to start forth, I've been currently on a project of building an autonomous soft robot to have potential application in search and rescue, and so far I've built somewhat of a foundation where the robot's able to be controlled in the forward and reverse direction digitally, but not yet autonomously, and currently the workaround towards this project is getting to a system where I could integrate it into a completely autonomous system. So I have a couple videos about building the foundation robot and kind of talking about inflatable robots in general, but in this episode I'm kind of going to be more talking about how to go about mounting sensors and rigid objects on to a constantly moving body. So to start forth, the reason why you might use these sensors to make the system autonomous, and why I'm using them to make it autonomous, is for the specific need and application that it's going to be autonomous for. Essentially, within a collapse structure, if you're looking for humans, you have to be able to identify where a human is and navigate the robot based on those different criteria. So what I really need to do this is a microphone array, something that looks like this. And essentially what that's able to do is give relativity, in a sense, to the robot and understand which microphone has the highest pickup, and basically articulate a group of servo motors to change the northwest, south, east direction of the robot and articulate its way through a constant loop of moving towards the human. One thing you have to identify in this process, however, is what is a human voice and what is an inanimate ambient noise. And this is especially common within collapsed structures where you might have a fire alarm going off or constant rubble falling, which all produce loud noises and sounds which you don't want the microphone to pick up on, and you only want it to pick up on the human voices or other calls for help. So one way of going around this is using a speech recognition system similar to the ones found in Siri, Alexa, and Google. And essentially what that's able to do is pick out the...
Is a multinational corporation in the United States of America. It is known for creating and...
Essentially what that's able to do, sorry about that, is identify the different pickups and calls which may be correlated to someone in help. However, one problem with that system is that it doesn't span across all language barriers, and someone's call to help can be different than someone else's. Someone may be yelling help where another person may be like yelling ah, so that doesn't really pick up on the main point of trying to identify human voice. So one way of actually going about this is using a voice activity detection system. So essentially what this is, it's a CNN that constantly reads from the microphone data and understands whether that may be human voice or just ambient noise. So this is actually somewhat common in like ANC headphones, and essentially what they do is if it detects human voice speaking, it will turn off the noise canceling to engage in conversation. So essentially we'll potentially be leveraging that software to identify human voice to further go around our articulated movements with our soft robot. So now that we know what software and what hardware is required to make our system autonomous, we have to look about a system of actually mounting the hardware to the robot. So this definitely comes into play with a soft robot like this because its system differs greatly from a traditional rigid robot. So essentially, in this use case, the process of the robot lengthening and growing is really what is our main concern. The soft robot essentially grows from the front through a process known as eversion. This is where positive pressure builds up within the robot, which feeds the inner plastic outwards, meaning that the front is constantly growing and the inside plastic is constantly becoming the outside wall of the robot. So essentially through this process, there's no fixed area on the front of the robot to attach a six-way microphone or four-way microphone array. So a workaround to this is using a couple ball bearings sandwiched between a plate to feed the inner tubing outwards, and I have a 3D design of that here. And essentially what that does is it feeds it outwards, yet it has a rigid structure to attach a sensor mounted to a pole to it. In this case, it would be the six-way microphone array to the rigid bearing structure. However, this has another problem because when it's feeding the plastic tubing through, there's still a layer of plastic tubing between the sensor pole and the bearing plate. So we kind of can't really get around that because we're never actually going to be touching the two rigid structures together. So we kind of have to leverage different principles, and that's where we can use friction and essentially use a bunch of marble-like ball bearings to essentially sandwich the sensor pole and hold it in place while the robot is growing. In my scenario, the plastic walls for my soft robot is kind of thin, and this is working more as a proof of concept. But in a scenario where I change some of the plastic walls and identify some of the drawbacks of this potential mounting system, I could apply it physically, but right now I've been working on it 3D prototyping it. But after that's done, we could definitely work our way to making this system completely autonomous.